Thanks for showing up, everybody. My name is Jeff Williams. I'm the CTO and co-founder at Contrast Security. I've been in application security for over 20 years. Along the way, I helped to start OWASP. I wrote the OWASP Top 10. I wrote a lot of open source tools and materials. And I've spent a lot of time working with really large organizations on application security programs and testing. I've done a lot of pen testing and code review. And for the last more than a decade, I've been helping folks make sure their APIs are secure. So in this workshop, we're going to automate API inventory, API security testing, API open source management, and API protection. And we're going to use a modern API security platform from Contrast. So let's jump into it. I talked about this earlier in my session earlier today. You can check it out. There's a lot more detail in the earlier talk, but in a nutshell, traditional API security tools lack context and don't do a very good job. From inventory to API security testing with SAST, DAST, and pen testing, static software composition analysis, and web app firewalls, none of these tools have the context to do API security very well. They were all built for monolithic apps and waterfall development styles back in the early 2000s. And when I say outside in, I mean, they don't know what's going on inside the application. That's the context they lack. And that's why they don't do a good job. And even if they did do a good job, you'd have to buy 4, 5, 6 different tools in order to do API security. That's too much. It's too complicated. So today we're going to look at a single platform that can give you interactive application security testing from inside the application. I'll talk to you about how that works as we go, but basically the idea is we're going to add an agent to your application or API platform, and it'll instrument the APIs and look at them from the inside. We're going to use that same agent to analyze open source usage. So not just see what libraries are listed in some configuration file, but what libraries are actually in use inside the running application. And we're going to use that same agent to detect attacks and prevent them from exploiting your application. Also using that same agent from inside and doing that analysis from inside the application, where you have much better context on what's happening inside the application. Therefore, you get much more accurate results and much easier to use and deploy. So again, check out the earlier talk if you want more context on that. This is a workshop. We're just going to focus on show and tell here. So I want to mention we do have a free community edition. So if you want to try Contrast on your APIs, you can do that very easily. So here's the setup that we're going to use today. And this is all available in let me show this in an open source repo on GitHub. It's under the Contrast OSS project, where we've got dozens of open source projects that we support. But this is just some sample apps in sample APIs in Java that you can use. And we're going to have 3 here. We've got a front end that's a Xxe API. It's got some endpoints that talk XML. We've got a data manager, which is a Spring Boot API running on a different port. These mostly talk JSON and serialized objects. And then we've got a developer service, kind of like a debug service, that's a Dropwizard API that's running on a different port and supports some debug information. So this is kind of how this fits together. And we're going to go through securing all 3 of these all at once. So let's get started. The first thing that you would do if you wanted to set this up yourself is clone that GitHub repo, then just build it normally. And it's a Docker project. So the directions are all there for getting that started. And if you want to use Contrast, then there's a few steps to setting it up. The first thing is you're going to add the Contrast dependency. So that looks like this in the main Maven file. All this does is it grabs a copy of this contrast.jar file. This is the Contrast agent for Java. Contrast supports Java, .NET, .NET Core, Node, Ruby, Python, Go, JavaScript, Scala, Kotlin, and PHP. So quite a lot of language support. It works pretty much the same way in all of them. First step is to install Contrast. Then you have to tell Contrast about your credentials. So here I've set up a YAML file that has my credentials and the team server I'm using. The team server runs in the cloud. That's where all your results go. So you can manage everything from one central dashboard. And we need some credentials to connect to that. And then the last thing is I'm going to tell the environment to use this Contrast agent that we've just downloaded it. Now we're going to tell it to use it. And the most important thing is this last line. This is Java tool options. It says -Java agent. So really, Contrast launches just exactly the same way that you'd use a tool like New Relic or App Dynamics or any other APM tool. We're like that, but we do security, not performance. And once these three steps probably take a few minutes. After that, every time you use these APIs, you're going to have continuous testing and production. All you have to do is your normal development process. You don't have to change anything about the way you build, test, or deploy your code. Ultimately, what you're going to see is we're going to have one platform to support most of what you need for API security. We don't do, kind of access control and authentication stuff, but all the rest of API security is where Contrast really shines. So let's take a look at how this works. So the first thing we're going to do here is start up this app. Oh, actually, I just started it. So if we scroll to the top here, you'll see it's way too far to scroll. I'll start it over again. So we're just going to do a Docker compose, and we're going to configure our project to start running. So you can there's three different apps here: the dev service, the front end, and the data manager. So that takes a few seconds to start up. So the next thing that we're going to do is once we've started up our APIs, we're just going to start using them. So the first thing we'll want to do is we'll go to the front end and we'll just list to see if there's any books in our service. So you'd be using curl. You could use any kind of tool, Postman, whatever. This is just, I thought it's simple for everybody if we just use curl. So here I'm just calling list on the front end. So we're getting XML back. And so here's the results. We've got 2 books listed, Dune and The Stars in My Destination. Kind of boring. You can also get some debug information on this service. Here's the, let me pull that up. So you can see here, we're just getting some info on prod, and this is kind of stubbed out, but normally you get, a bunch of debug information. Let's add a book. This is a little more interesting. So we're going to, you can see we're calling the add function, and we're sending a payload of an XML document here. You can see we're uploading a book called Catcher in the API, and we're going to upload that. And now when we call list, we'll do that list again, and you'll see, hey, now we've got a new book in our database for Catcher in the API. You can add, a bunch of books that way. There's a couple other endpoints here that we want to show. We can do a health check on the entire bookstore here. So you can see we've got 2 services running, the data manager and the dev services. Both currently are healthy. And I think I did our debug one, so we're done. So that's mostly the whole API. And you're probably sitting there thinking like, hey, Jeff, what are you doing? When do we start the security testing? Well, guess what? We're already done. Let's go to see what Contrast has found out about these applications already. So when you go to your Contrast dashboard, you get a picture of kind of everything that you're monitoring. Here I've got 33 applications that I'm currently monitoring. We have customers that have thousands of applications because because it's a distributed solution, it's very scalable. All the testing is done locally and the results come together here in the central server. So there's no scanning. I want to make that really clear. We're not scanning anything. We're monitoring applications as they're run during normal QA testing and in production. So this is just from your main dashboard, you get an interesting view here. You can see, hey, I've got a bunch of libraries. I've got some vulnerabilities. I've got a lot of custom code vulnerabilities, and I can see production. I can see it where I'm being attacked. And really, there's not any other product that will show you both the pre-production vulnerability side of things and the production attack side of things all in a single dashboard. I've never seen anybody assemble this, from a variety of products. So it'll be like taking your SAST and your DAST and your SCA and your WAF and your gateway and pulling all the data from those together into a single dashboard. We've done that for you. So let's look at what we've done so far. So when I pull up the applications tab, I'm going to have to log in here, log me out. Contrast has automatically identified any APIs that are running on those servers that we just started up. In this case, it found 3 different APIs and reported them to the team server. So I'm going to select those and merge those together into a single project, because for me, this bookstore is a collection of APIs and I want to manage them together. So I'm going to choose the front end here as the main project name. Then I'll just merge them together. This is nice because now I can just have one project with all my APIs in it. So that's some of how we handle inventory here. Now, when I look at this, you can see, I have visibility into development and QA and production. So I can see what's going on in all 3 environments. I've already analyzed all the libraries. We'll look at that in a second. And I've got several servers reporting in already. So let's go to the vulnerabilities tab here and see what we've done. So just by using this application for a couple of minutes, you can see we've discovered some vulnerabilities. Most of these were discovered in just the last few minutes. And we didn't have to do any security testing. Like, notice I didn't hack anything. I didn't try to exploit any vulnerabilities. I just did my normal testing. Let's take a look at this external entity injection, this Xxe here. So what this says is when we called the add page, when we added that book catcher in the API, we discovered a vulnerability. And here's what Contrast is telling me. It says, hey, you just detected a vulnerability. We're going to track a timeline until it gets fixed. We report the details of the HTTP request here. So here you can see the actual XML. You can see the book, the title, catcher in the API. You can see the number of pages, 666 here. And we traced that XML data through into the class and method where that data was referenced. And we saw it get read and turn from an XML into a real document. So this is why we read into a real object. So we read that on this line of code, line 42 on book service. So this is telling me this is vulnerable to an Xxe attack. And if I add an attack that looks kind of like this, I may be able to access other files on this server. So let's take a look. We don't have to do this. We could, we found this vulnerability. We could trust it, but hey, let's make sure that it's really one. So I'm going to exploit this vulnerability for you. And I'm going to use the same kind of curl request here, except this time I'm going to send a malicious book in XML. So here's the malicious book, okay? And notice that I've added a doc type to this. So this section right here is the essence of an Xxe attack. It defines a malicious entity named Xxe that when that entity is referenced in the XML document, it will call this, make a system call and read in the Xxe password file. And then it'll insert it where this entity is translated back, interpreted. So that we define a new named entity called Xxe, and it'll be inserted right here, right after the art of war. We'll put the contents of the password file. So let's send that request up. And then so that's great. How do we know if it worked? Well, let's call that list again, the list function, and list out the books we have here. Now you can see in the list of books, we've got the books that were there, and then we've got the art of war. And then remember the Xxe entity that I defined as the password file, it reads the contents of my password file right into the document. Now, what could I use this for? I could use this for a lot of things. I can reference any file on the system here. I could also use this to access backend systems You can even implement a sort of a intranet scanner this way by using Xxe to reference backend systems with URLs, and you can find out if those systems are up and available. So this is a really powerful attack technique that we can execute right through an API vulnerability. I'm getting a message that says the bottom part of my command line is not visible. Is that true for everybody? I'm sharing my whole screen, right? Let me know if there's any other issues there. Yeah, so look, all we did is, we used Contrast, we added it to our platform, and from that point forward, we're going to be testing every time we use an application. We're going to be finding vulnerabilities. We're going to be analyzing libraries and so on. Let's go back to the main dashboard here and take a quick detour into libraries and other things that we've discovered. Actually, let's finish this out real quick. So now we know that this is a real vulnerability. Contrast detected this by watching it happen. So generally, you don't have to exploit these vulnerabilities. You don't have to know how to do Xxe attacks. You can trust that Contrast has found a real vulnerability here when it reports it. And we give you all the proof that you might need. So we watched this attack, this use flow through the application. This is the original one when I wasn't attacking. I just, sent normal data in. We traced that data through the application from the line where it was read in, through a couple of input stream wrappers here, and then finally into the code on book service line 42. And you can drill into that. You can see the state at that point. You can even see the full stack trace that was recorded directly out of the running application. So you can see exactly how this thing got invoked and why. And this is really powerful, right? We've got the exact details here. I can even go, right into my IDE and pull up the book service, go right to line 42, and I can see this is exactly the place where that input stream was marshaled into a book object. That's when the XML gets parsed, and that's when the entity gets interpreted. So this is where you want to think about making sure that the XML parser used here doesn't allow doc types. It doesn't allow entities to be resolved, because really you shouldn't have that turned on in your XML parser. So that's the feedback loop. What we're trying to do is get vulnerability information back to the people that need it through the tools they're already using in a really fast way. And you can see we've got plugins into various environments. You can see here's here's the XML XML external entity injection. We can pull up the details on that, and you can get all the details you need right in the IDE. So let's go to the libraries stuff. So while Contrast was starting up and while you started using the application, Contrast also analyzed all the libraries, all the open source use in the application. So here you can see across these different services. So you can see the data manager, the dev service, and the debug manager here. You can, and the APIs. You can see all the libraries that get used across this application. And it's a lot. It's 183 libraries across all of these different APIs. That's a lot. But we want to focus in on the ones that are vulnerable. So I can pull this down. I can focus on either the ones that are vulnerable or the ones that are a policy violation. And the policy violation is you can set a rule on like how many versions out of date do you want this to be. Like you got to be within 20 versions of the latest here, but that's configurable. So I want to filter this down. I want to say, hey, show me the ones that are vulnerable. These have known CVEs associated with them. So now I'm down to 25 that I really need to focus on. These have CVEs. You can prioritize them based on their severity level and so on. But the real interesting thing about this type of analysis is that I can filter down just the ones that are used. And so this allows me to have visibility to just the libraries that are actually used at runtime. And it turns out only 38% of libraries are ever invoked at all. So that leaves, 2/3 of the problem is libraries that are never used. They're just, second order dependencies that are included in projects that really don't affect your security very much. So I really want you to focus on this. Contrast reports to you not only which libraries are used and vulnerable, but you can actually even drill into this and see exactly what classes are used inside this library. So here I can see here's the only, what is this, 9 classes that are actually used inside this common collections jar. So really powerful way to filter down on exactly what you need to focus on for open source security. There's a couple other reasons why runtime library analysis is the right thing to do, rather than running a SCA tool on your code repo. If you analyze a code repo, you're probably going to see libraries that don't belong, because you'll see libraries that aren't really used at runtime. So for instance, you'll see test libraries and things like that. And you'll miss critical libraries. Like some of these libraries, like the ones that come with Tomcat and Spring, some of these libraries come with the app server, and they're only visible at runtime. They're not visible in your code repo because those libraries aren't defined there. So I really encourage you to actually look at the running application as your source of truth. That's where you're going to find out what's really vulnerable in a real application. So we very quickly here were able to analyze this application for custom code vulnerabilities, for libraries. Let's look at a couple other kinds of vulnerabilities. So the next one we're going to look at is an untrusted deserialization flaw. And this is for APIs that use serialization, and they're getting serialized objects from an untrusted source. I think, who was it? I can't remember. There's a very large vendor that just had one of these. It might have been WebEx. Just had one of these in their, I'm pretty sure it is. They had just had an unsafe deserialization flaw in their main product. So it's really very timely. So here's how this works. In the back end for this, we can add books a different way. We can use JSON to add this book directly to the back end. And of course, this back end may not be directly accessible by the attacker. That would be a smart way of doing things. But the fact is, in the real world, it's very difficult to guarantee that APIs are not directly accessible, whether it's, straight from the internet or, through some other flaw. They could be invoked by an attacker remotely. And so I think it's a good philosophy to treat all APIs as though they were publicly exposed. That way you'll put the right defenses into every API. And if they're inadvertently exposed, you'll still be protected. So here we're contacting the data service directly, and we're calling the add method. The data service, if you remember, takes JSON requests. So I'm going to add Apiacalypse now, and we'll add a book that way. So now when I look at the list of books here again, we've added the new book, Apiacalypse now, and so you can see how this interface works. So I'm gonna add books another way. There's another way to add books to this backend using serialized objects. So here's how we do that. I have a few books serialized, and actually I'll show you it's very simple code to serialize an object here. We're just literally creating new books and writing them out to SER files. So I've got 3 of them: Great Expectations, a serial thriller, and a pair of dice lost. And so those 3 books, we can push them to the API this way through the update method, which takes a serialized object. So I'm going to push those 3 books real quick here: book 1, book 2, and book 3. And now when we do the list, you can see we've added all these books. Here's Great Expectations. Here's some of the other ones: serial thriller and pair of dice lost. So we've got our books. We've located them. So now I know I've exercised this code. I've just used that API. And guess what? Contrast is there in the background doing the security testing on those APIs. As you do your normal testing, Contrast is there adding security testing automatically. So now it's really, it makes your security teams and your quality teams aligned. All you have to do is drive that coverage of automated test cases up, because this works just the same way when you're running automated tests. In fact, it would be better if we were running automated tests for all this. So here we've discovered another thing. We've discovered an untrusted deserialization flaw in the update page. Let's take a look at that. So here what we see is same kind of thing. Update page, deserialization flaw, start the timeline, and we can see, hey, we got a serialized object here. It flowed through the application through this update book method on line 51, and it ended up in being deserialized as into an object at that point. The reason that's a problem is because when an attacker can control deserialization, the way it works is, the deserializer looks at the data that's coming in and instantiates instances of the objects defined in the serialized object. So it works great if the object is a book, but what if I put other kinds of objects into that serialized object? Well, then the code is going to create those. And attackers have been very creative at coming up with ways of creating strings of objects that will allow them to run arbitrary code on your servers. And we'll do that in just a second. But here, let's look at the details, because I think this is interesting. So here we see this serialized object get read in, flows through some input streams, and eventually goes into this stream.read object call on data service line 51. And again, you get the full stack trace. We can jump right to the code there in our IDE. We got plugins for all the major IDEs, but here's that book data service on line 51. You can see this is where we've taken, just the request input stream, the body, and pumped it right into the read object call. So there's no protection against unsafe deserialization here. So let's take a look at exploiting that. Before this call, this is like a cooking show. Before this call, I created a malicious serialized object. I call it badbook.ser. And inside it, it creates a serialized class from the Apache Commons collections library that will allow me to, when it gets instantiated, it will allow me to run arbitrary code. So I set it up so that when that code gets deserialized, it's going to touch a file in the temp directory called /temp/hacked. So if this works, then that's what's going to happen, is a file is going to show up in my temp directory telling me that it happened. So let's do this. Let's try sending the I changed this to that's what I get for practicing my demo. Badbook.ser. Oh, I got to send it to update. That's so here we go. I've sent it to update, and it says, oh shit, oh man, I'm blowing this. I should have practiced this a little more. So I don't need XML output here. So this is interesting. It says, I get an error message that says, hey, bad value exception, cannot cast this to book. Well, yeah, you can't cast it to book because it's not a book. I didn't send a book. I sent a malicious collection object. So let's see if the attack actually worked. So we're going to go Docker. Yes, we're going to look up the data manager here, and we're going to get the ID for the data manager. That's this thing, and we'll just go Docker exec that container, and we're going to do ls/al/temp, and so here you can see we've got our hacked file here that just got created. Did I do the right? Yeah. So That's really scary. That means I could run any arbitrary code that I want here just through this simple vulnerability. I could run almost any code. I could take all your files, steal your code, connect to the back end. I could do anything that that code could do on that system. So powerful attacks. Let me know if this is all clear in the questions. If you have any a question about this. I see one question that says, do you also propose a JVM agent? I guess the question is here, like, how does it get packaged? And we did go over that a little bit at the beginning. If you look at this slide, basically we're just adding this Java agent. We're downloading it, we're giving it credentials, and we're telling Java to use this Java agent on these 3 different Docker containers, and that's it. Once you set this up, these 3 steps, then from then on, you're going to be continuously testing. Let's do one more. I think this is just so fascinating to find vulnerabilities without actually having to do any security testing. We just do our normal development process. So let's do one about Ssrf. So Ssrf stands for server-side request forgery. And basically what it means is, can an attacker trick your API into emitting an HTTP request to some other system? So if there's a way I can send some data that will trick your API into sending an HTTP request out, maybe to a URL that I control, then I may be able to do malicious stuff in your back end. So here, let's use the dev service here, that debug service I was talking about. So again, we're just going to use it normally, right? So here I can query it. I can say, hey, give me some debug information about prod, and sure enough, I get some debug information about prod. I can also think about manipulating this prod here, but let's see what Contrast found, and it'll tell me how to do this. So when I go back to the vulnerabilities here, let's refresh this. You can see, I don't see it. Oh, here it is down here. Here's my Ssrf. And you can see what we did. We sent in this request, environment equals prod. Contrast traced that data through the application into this method, this line of code, and you can see where the data ended up. And this is really powerful. Like if I was trying to detect this at the perimeter or from the results, it would be very difficult because all this happens inside the API, invisible to everybody. There's no observability normally. But Contrast has exposed this. It says, hey, that parameter goes right into the beginning of a URL. That means as an attacker, I could manipulate it. So what could I put in there? Well, I could put in almost anything, but I'd still have to deal with this, .acme dev info stuff at the end. So I want a way of chopping that off of the URL. And the thing I could do is I could put a question mark in there so that it thinks all this stuff is a parameter. So let's do that. We'll put in something that looks like, I'll do it by curl first, and then we'll look at it in a browser. So we've discovered this vulnerability. So what I'm going to do is I'm going to just go to this URL and put google.com in, replacing that prod with google.com, and then I'm adding a question mark at the end so that it chops off the extra parameters. And sure enough, look, I get basically the Google homepage back. So I'm kind of tricking this API into being a proxy for me. And as a hacker, I'd be very happy to get a proxy inside your business, inside your data center. I have a proxy that I can send HTTP requests to whoever I want. Go straight past your firewall, straight past your gateway. I can get data from anything I want inside your enterprise. So that's pretty powerful. And if you want to see this work, you can even do this right inside a browser. I'll show that here. Same thing. I just put the question mark at the end. %3f is question mark. And so you can see I'm actually like clicking through into Google. So this is a powerful Powerful attack, powerful technique, and we were able to find it very easily. So we've got a few minutes left. So what I want to do with the rest of my time here is actually, let's show the details here, just for completeness. We'll show the details. So here's the prod details. You can see exactly how that data flows into this URL. You'd probably want to add some verification of this URL. You could, create a placeholder that says, prod, but you don't want to combine data directly into URLs. And of course, for all these, we have the full HTTP request. So you've got a test case that you can use to replay this anytime. So compared to static and dynamic tools, remember, a static tool is only going to give you this line of code. It's not going to show you, what's really going on. A dynamic tool is only going to show you this. It's not, and then have some attack payload here. It's not going to show you where in the code you need to go fix it. And no tool is going to show you this full integrated data flow piece to show you exactly how the attack ends up in a vulnerable place in your data. So putting it all together in a single story is really powerful. And what it does is it allows developers to fix these things much more reliably and much faster. So so that was great. We in a few minutes, we were able here to identify a bunch of vulnerabilities. We didn't have to know anything about security. Anybody can do this. Any developer can do this and get details on what they need to do to fix these vulnerabilities really quickly. We also analyzed all our libraries. We found, all the libraries that are both vulnerable and used. So we can zoom in on exactly what libraries need protection. But the last piece here, I think, is really powerful. And this is runtime protection. So I want to show, I'm going to go up to the attacks tab here, and we'll just see a few attacks here. The 3 attacks we've been trying, right? Untrusted Deserialization, external entity. We've seen these attacks. Let's take a look at the attack events here. So currently I have Contrast running in detect mode. It's just detecting these attacks. It can also block these attacks. So it's exactly the same. You flip a switch and then you're blocking these attacks. I just want to show you the details here. The first one we did was Xxe, and we can pull open all the details here. Remember the attack I did, the Art of War, and I asked for the password file. Contrast detected that and noticed that, hey, this payload worked, put the password file into the HTTP, into the data structure that then was exposed, and gives you all the details of this attack. So whether you're using the assess piece or not, you can protect your applications from being exploited with Contrast. And so here we've got the details of the attack. We've got the full stack trace, got the full HTTP request again, and much more accurate here than what you could get from a WAF. WAF is at the perimeter, and it doesn't understand how this data was used. There are lots of ways to obfuscate this attack in a way that WAFs can't detect. But because we're seeing this, right at the line of code that calls the XML parser, we can be super accurate about this attack. So we tried untrusted deserialization here, and you can see here I sent this malicious serialized object, and we tracked that through to the line of code. We said, hey, this exception was detected, and you can see the full stack trace, of course, the full HTTP request, and so on. So we have real confidence that they're serious attacks and would have exploited these applications if Contrast hadn't been there. Now, of course, flipping this to blocked, then all these attacks that we've done won't work. And I want to tell you a little story about Log4Shell and Spring4Shell, both of which came up in the last few months. Both were vulnerabilities in open source libraries that ended up being pretty devastating. Log4Shell allowed attackers to take over an application simply by sending some untrusted data that within a specific format that gets passed to a log call. So something that almost every application does. Contrast detected that attack and prevented the exploit from running even before that vulnerability was made public, because the underlying attack was either expression language injection or unsafe deserialization, just like this one. And Contrast prevents those attacks from being successful. So all of our customers that were using Contrast were safe against this. So we're safe. We protect you against both libraries, both custom code and libraries, whether the vulnerability is in your custom code or whether the vulnerability is in your library code. Contrast is there making sure you don't get exploited even before you know the vulnerabilities are there. And it's the same thing for Spring for Shell. Again, we were super happy that we were able to help our customers with this, because Contrast identifies the exploit techniques that that attack used. So we were able to prevent those attacks from exploiting the vulnerability in those applications. That's a pretty powerful capability to have, because there's no question that there are going to be more problems in libraries. In fact, for Log4j, within a few days, I think within a week of the discovery of the first vulnerability, 3 other vulnerabilities were found in Log4j, just because people were interested and dug into it and started looking at that code. What that tells you is there's lots of latent vulnerabilities out there in open source code just waiting to be discovered. I mean, you got to remember, all those open source vulnerabilities that you hear about, those are discovered by a small handful of volunteer security researchers discovering those vulnerabilities because they love what they do. But it's not nearly enough people to secure the vast a number of open source libraries that are out there. So there's plenty of vulnerabilities out there to discover, and you need to have some kind of protection against those, some way to respond to those when they come up. So having RASP in place protects against a broad range of attacks. And I'll just spend a minute showing the kinds, the range of vulnerabilities that Contrast covers. So you can manage all of your AppSec policy from one place with Contrast. So here's assess rules. These are the kinds of vulnerabilities we find in your APIs. And you can see there's quite a broad list of kinds of vulnerabilities, from insecure encryption to hard-coded passwords, all kinds of injection, to HTTP kinds of vulnerabilities. It's really quite a broad range of vulnerabilities that this technique can find, because IAST has so much context. It's really quite broad protection. And then there's the protect rules. These rules are for attacks on production applications. And here you can see quite a broad range of, it's similar list to the kinds of things we can detect in pre-production. So we can stop all of these kinds of SQL injection, all kinds of untrusted deserialization, Xxe, and so on. So that should give you a sense of the breadth of these techniques. And I strongly encourage you not to deploy applications without runtime protection. So there's a question here. It says, to be sure, you do the analysis of the Java libraries, but not the OS itself. And the question is, are you talking about operating system or open source? And Contrast does both analysis of, okay, so yeah, we don't analyze the operating system. There are plenty of other products that work farther down the stack. Contrast analyzes the application layer and up. So like Java and up, .NET and up. So we analyze, the platform, the frameworks that you're using, the open source, and your custom code. And we analyze it all as one thing. And it's always seemed foolish to me to use different tools on, when you look at this chart, you'll see, well, I'll show the original one. Security testing and open source testing are mostly done by two different tools, which is weird because custom code and libraries combine together to make an application. You can't really do custom code security testing without understanding the frameworks and libraries that are used in that application. And vice versa. You can't understand the security of the libraries unless you know how that custom code uses those libraries. It's one thing. And you're only going to get half the picture if you analyze them separately. So Contrast, we analyze them all at the same time. So we see, how your code uses those libraries and reports vulnerabilities. Sometimes we report vulnerabilities that are entirely in custom code. Sometimes we report vulnerabilities that are entirely in open source code. Previously never discovered vulnerabilities. But most of the time, vulnerabilities actually span your custom code and libraries. So Log4j is a good example. In order for you to have a Log4Shell vulnerability, you have to be logging untrusted data. That's in your custom code. So there's a piece that's kind of what you did. And then there's a piece that's in the library that says, hey, we're going to take that untrusted data. And if it follows a certain format, we're going to do this really crazy, powerful thing and allow you to remote load, through RMI, we're going to load code and run an exploit. So it's important to think of AST and SCA as one thing. It shouldn't really be two separate things. And that's sort of Contrast's philosophy there. So if there are any questions or anything anybody wants to see, we've got a few more minutes here before I have to wrap up. I'll just go back to the main dashboard here and sort of focus on our value proposition here. We are focused on creating observability and protection around your whole application ecosystem. And APIs is a huge part of that in modern applications. I should mention, we also do support Lambda. We've got instrumentation, like an engine that you can drop into your AWS environment, and it will inventory all your code there, find three kinds of vulnerabilities. It'll find custom code vulnerabilities, it'll find library vulnerabilities, and it'll find identity and access management permission vulnerabilities. So we'll find if any of your functions are over permissioned, we'll actually rewrite your permission grants to minimize, to give you least privilege around those functions. And it's something that our customers have found incredibly useful as they go forward with Lambda. There's a good question around, is Contrast and its RASP capabilities language agnostic? Like, will it work equally well in a .NET environment? And the answer is yes. We do have a separate agent that works in the .NET environment, and all our language environments have a separate agent. But they all report into this same dashboard. You can see in my my app portfolio, you'll see applications here that are in Java and .NET and Node and Ruby and Python. Here's a .NET Core app, and so I think I have mostly Java stuff here. But we support a broad range of languages and frameworks in Contrast. So I just scratched the surface of what you can do with Contrast, but again, our goal here is to help you scale application security across hundreds or thousands of applications. We are used in production in hundreds of large companies that protect their front door, their internet-facing APIs all the time. And if you're interested in finding out more, we'd love to talk to you. You can connect with me on LinkedIn. I posted at the top of the chat, I posted my LinkedIn. You can find a lot more information on the website, or you're welcome to reach out to me anytime. If there's any other questions, I'd be happy to take them in the chat.